In this example, we find a singular value decomposition for a 3x2 matrix. The singular value decomposition for this matrix is going to be a product to form A equals U sigma V transpose. Now we get this, we get sigma and V transpose by finding the eigenvalues and eigenvectors for A transpose A. A transpose A is going to be 1, 0, 1 minus 1, 1, 0 times 1, 0, 1 minus 1, 1, 0, which gives us a matrix 1, 0, 1 is 2 minus 1 minus 1 by symmetry, then 1, 2, 0, so 2, negative 1, negative 1, 2. The determinant of AA transpose minus lambda I, so 2 minus lambda, minus 1, 2 minus lambda. And so we get 2 minus lambda, 2 minus lambda, minus 1. This is lambda squared minus 4 lambda plus 4 minus 1 is plus 3. And that factors to lambda minus 3, lambda minus 1. Okay, so lambda here is going to be 3 and 1. And so our singular values are going to be root 3 and 1. So our matrix sigma is going to be root 3, 0, 0, 1, 0, 0. Because again, our matrix sigma has to be the same dimension as A. Okay. Next, let's find our eigenvectors. For lambda equals root 3, or lambda equals 3, we're going to get the matrix 2 minus 3 is minus 1, then minus 1, then minus 1, then 2 minus 3 is minus 1. So x is equal to negative y. So if y is equal to 1, let's say y is equal to negative 1, then x is equal to 1. And we normalize that by multiplying by 1 over root 2. Okay. Next, we have lambda equals 1. So our matrix here is going to be 2 minus 1 is 1, then negative 1, then negative 1, and 2 minus 1 is 1, times x and y equals 0. So here x is equal to y. So the eigenvector 1, 1 works, and we'll normalize it by multiplying by 1 over root 2. So this gives us our vector v. Our vector v then is going to be 1 over root 2, negative 1 over root 2, 1 over root 2, 1 over root 2. Good. So A is equal to U sigma V transpose. We have V, so we can figure out V transpose. We've got sigma. Now we need U. So U1 is 1 over sigma 1, so 1 over root 3, times matrix A times our first vector here. So that's 1 and negative 1 times 1 over root 2. So we'll go root 2, root 3 is 1 over root 6 times, we've got 1 and 1 is 2. We've got 0 and negative 1 is negative 1. We've got 1 and 0 is 1. So that's our U1. And our U2 is going to be 1 over 1 times A times our vector V2. So that's 1, 1, and 1 over root 2. So we end up with a 1 over root 2 out front. And then 1 minus 1 is 0. 0 plus 1 is 1. 1 plus 0 is 1. So 0, 1, 1 normalized to be 1 over root 2. We still need a third U vector, one that's perpendicular to U1 and U2. So we want U3, it's ABC, so that U1 dot U3 is 0. So we know that, so if U1 dot U3 equals 0, then we've got 2A minus B plus C equals 0. And if it's perpendicular to U2, then we've got U2 dot U3 equals 0. So B plus C is equal to 0. Okay. And we can just sort of go ahead and take any vector we want in this direction because we need to normalize it anyway. So if we take C equal to 1, B has to be negative 1. We get B plus C equals 0. Then we've got 1 plus another 1, which makes A minus 1. And so we've got 1 over root 3 to normalize it. Great. That gives us enough for our matrix U. U is going to be U1, so 1 over 2 over root 6, negative 1 over root 6, and 1 over root 6. U2 is 0, 1 over root 2, 1 over root 2, and then finally here, negative 1 over root 3, negative 1 over root 3, and 1 over root 3. So this gives us our matrix U. So A is the product of our matrix U times our matrix sigma times the transpose of our matrix B. And you can confirm that by simply multiplying that out.